Okay, good day, everyone. We are now on the second or part two of the discussion about Venn diagram. So we are now on focusing on the complicated illustration as well as understanding about Venn diagram quantitatively. Okay, considering example here, out of 40 elements, 14 are taking English composition and 29 are taking chemistry. So how would you put this into an interpretation? So we are required first to answer or to address the requirement ABC. In letter A, you're required to find how many students are in neither class. So if 5 students are in both classes, how many students are in neither class? Letter B, how many are in either class? And letter C, what is the probability that is randomly chosen student from this group taking only chemistry class? So we will proceed to the illustration first. Based on the premise that we have, 5 serve as the common between the two sets, comparing the English composition class and chemistry class. So 5 serve as the intersection between the two. So this is the common quantity. Remember, we're not talking about the roster set here. We are talking about quantity given. So going back to the out of 40 students, 14 taking up English composition, 29 are in chemistry. If 5 students are in both classes, how many students are in neither? In order to address that problem, so we should have illustrate it first in the Venn diagram. So we have 5 as common. And notice that there are 14 taking English composition, while 29 in chemistry, out of 40 students. Okay? So, in order for you to understand more on the illustration, so 5, since 5 is common, and there are 14 students who took up English composition. Since 5 is common, so we should have to deduct or subtract 14 by 5 so that 9 would serve as the remaining students who took up English composition only. So with the chemistry class, there are 29 who enrolled in the subject. But since 5 is common, so 29 to be subtracted by 5, we have 24 students included in the class for chemistry only. So that if we will try to add all those obtained value quantity in each what is this? In each class. So what we are going to do to find the number of students who are not included, or how many students are in neither class. So in this case, to add 24 plus 5, we have 29 plus 9, we have 38. So 38 out of 40 students, so 40 minus 38, the difference is 2. So these two students are not enrolled in English composition as well as in chemistry. So that answers the question in letter A, how many students are in neither class. For letter B, how many students in either class? How many students in either class? So there are 38 students. And letter C question, what is the probability that randomly chosen student from this group taking up only chemistry class? Okay, so it's here. To find the probability, just divide, since 24 students by 40. And we have 3 out of 5, or equivalent to 60% probability. Okay, let's continue. Example number 4. 100 students were interviewed. 28 took PE, 31 took biology, 42 took English, 9 took PE and bio, 10 took PE and English, 6 took biology and English, and 4 took all 3 subjects. Question, how many students took none of these of the 3 subjects? B, how many students took PE but not biology or English? Meaning PE only. Okay. Let's have an illustration. The common being mentioned here is there are 4 students who took all 3 subjects. Going back to the statement, there are 31 students who took, 9 students who took PE and biology. So if there are 9 students who took PE and biology, 9 minus 4, so 5 serve as the common between PE and biology. The same thing with PE and English. There are 10 who took up PE and English as common. But there are 4 who took up 3 subjects. Therefore, 10 to be subtracted by 4 is equal to 6. Serve as the common quantity between English and PE subject. For biology and English, we have 6 students who took up PE and biology, and we have to subtract it by 4 again, so that the difference is equal to 2. So meaning, whatever is the given in the problem is always affected by the common students who took up 3 subjects. And that from inward, we will move for outside process. So, in order to determine exactly the number of students who took up each subject only, for PE, we have 28 students. And there are 4 students who took up 3 subjects. And there are 6 students only who took up PE and English. And 5 for PE and biology. So meaning that total value, which is 28, should be affected by those 3 deducted elements already. So to find the value, 28 will be subtracted by the sum of 5, 4, and 6. So that 28 minus 15, the difference is equal to 13. So there are 13 students who took up PE only. For biology, since we have 31 students originally in the class of biology, but we have to subtract it by 4, 5, and 2. The sum between 4, 5, and 2, which is equal to 11. So 31 minus 11 is equal to 20. For English, originally we have 42 students. That 42 students will be subtracted by 6, 4, and 2. Sum of between 6, 4, and 2, which is equal to 12. So 42 minus 12 is equal to 30. And for the remaining value in the universal set, since you are talking about (100) students were interviewed. So that 100 will be affected by the sum of the number of students in each subject only, to be added by the common in 2 subjects, which is 6, 5, 2, and the common between the 3 subjects, which is 4. So adding 13 plus 6 plus 4 plus 5 plus 2 plus 20 plus 30, their sum is equivalent to 80. So that 100 minus 80, the difference is equal to 20. So there are 20 students who we put outside the intersecting 3 circles, and that would be the remaining elements in the universal set. So the answer to the questions, how many students took none of the 3 subjects? So there are 20 students. For B, how many students took PE but not biology or English? There are 13 students only. We continue. Example number 5. In a group of 60 people, 27 like cold drinks and 42 like hot drinks, and each person likes at least one of the 2 drinks. How many like both cold and hot drinks? So we let A as a set of people who like cold drink, and set B for the people who like hot drink. Given in this case, in a group of 60 people, meaning this would be the cardinality between the union of set A and set B. So we have 60. And the cardinality of A is exactly 27 originally, and the cardinality of B is 42. Now, if we are required to find the A cardinality of A intersection B. By the way, why cardinality of the intersection? Meaning we are considering the idea of finding how many students like both cold and hot drink. So we are pertaining to the intersection between the two sets. So we can solve it in this particular formula to find the cardinality between the intersection of A and B is equal to the cardinality of A plus the cardinality of B minus the cardinality of the union between A and B. So substituting the values, 27 is the cardinality of A plus 42 as the cardinality of B to be subtracted by 60 as the cardinality of the union between A and B. So the cardinality of the intersection between A and B is equal to 9. Meaning there are 9 people, both cold drink and hot drink. So you have this, again, activity number 3. Perform this accordingly. So we shall now proceed to the next example. Given that the cardinality of the universal set is equal to 50, and the cardinality of A is equal to 25, and cardinality of B is equal to 20. Question: to find the greatest value of the cardinality on the intersection of A and B. Now, as you notice, based on the formula, considering the cardinality of the intersection between A and B is always equal to the sum between the cardinality of A, which is 25, to be added by the cardinality of B, which is 20, minus the cardinality of the union between A and B. So in that case, letter A requires us to find the greatest value of the cardinality between the intersection of A and B. So we can interpret this in this manner. The greatest value should be equal to 45. So how can we get this? Considering that the sum of A and B is also 45, so the intersection will be equal into 45 if the union between A and B is equal to 0. So meaning the least, the greatest value we have in the intersection between two sets should be the less compared to the least value also of the union between two sets. So if the total between the cardinality of A and B is 45 out of 50. So the greatest value of intersection between two sets are 45. And the least value of the union between the two sets should be 0. So 45 compared to 0, that is the relationship that we can consider here. As well as, if we would want also to find the least value of the cardinality between the intersection, so we have 0 value to be the least compared to the greatest value of intersection between, or the union rather, between the two sets is also 45. So it is an inversely proportionality, or we are observing descending and ascending order of its two relationships. So, perform also the next activity. Try it. Example number 7. In a group of students, 65 play football, 45 play hockey, 42 play cricket, 20 play football and hockey, 25 play football and cricket, and 15 play hockey and cricket. And there are 8 play all 3 games. Question: the number of students to play football, number of students who play hockey only. Letter C, number of students who play both football and hockey. So before obtaining the answers here, we should have to consider the illustration in the Venn diagram. So how we get the number of students who play football? So the given there are 65 play football. Notice that 8 play all 3 games. So to find the difference between since our concern is to find the number of students who play football only. So we have to subtract, since there are 42 who play 20 rather play football and hockey, and 25 play football and cricket. So we must have to subtract 25 by 8, and the difference is equivalent to 25 by 8. 17. So 17. And to play football and hockey, so 20 we subtracted by 8, we have 12. 17 for football and cricket, 12 for football and hockey. and 8 to play 3 games. So 65 will be subtracted by 17 plus 12 is equal to 29. Plus 8 to play 3 games, we have 36. 65 minus 36, and that is 28. To letter B, number of students who play hockey only. The answer is 18. So, we have 45 to be subtracted by 8 plus 17 plus, 15 minus 8 is 7. 45 will be subtracted by 17 plus 7 plus 8. So that their difference is equivalent to 18. So there are 18 students who play hockey only. The number of students who play both football and hockey, originally it is 20 to be given. I think it's given already, 20. So, I illustrated this already during our discussion in the classroom. So, I hope we guided also. It will serve as a review. Perform activity number 4. Okay, so much for this episode. Goodbye, everyone. This is your teacher, Cedric Borres. Thank you.